Yeah, today we're going to look at 10.4 polar coordinates and graphs. If you remember from pre-calculus that rectangular coordinates are xy, polar coordinates are r theta. R stands for the radius, theta stands for the angle that opens up the radius. So I drew a little picture here for you. Okay, xy is that point here. However, in polar, it's going to be r with the theta there. Okay, so over here we have a circle. This would be an equation of r equals 1 without any theta. It's just the first circle on a polar graph. That's it. It's the circle with radius 1. If I wanted radius, like, if I wanted like r equals 3, then all it would be the third circle in, and it would look like that. That would be the answer. It would be a circle. And the reason why is because of the following. Here's some identities or some definitions that you should know. X is r cosine theta, y is r sine theta. The tangent is equal to y over x because it's sine over cosine. All right, and the cosine squared plus sine squared equals 1, or I will say x squared plus y squared equals the radius squared. So if the radius is 1, okay, that's just 1 squared is 1 equals x squared plus y squared. That's it. So that'll make this equation 1 up. I might be writing on myself here. 1 second. 1 second. That'll be, so using this equation, it would be 1 equals x squared plus y squared. And that's why you recognize this guy to be a circle. Or let's move it up to here. There you go. Some more stuff. We're going to go rectangular to polar. I'm sorry, from polar to rectangular. So I'm going to show you how to convert back and forth. All right. Polar coordinate. I'm given 2 pi. All right. These are 2 different problems. So this is number 1. This is number 2. Okay. 2 comma pi. All I got to do is put it in here. 2 cosine pi, 2 sine pi. 2 cosine of pi is negative 2. Sine of pi is 0, so it's negative 2, 0. And there it is. I know I make it look so easy sometimes. Over here, let's go crazier. This is square root of 3 pi over 6. So, if I want, x equals the square root of 3 times the cosine of pi over 6, and y equals square root of 3 times the sine of pi over 6. So the cosine of pi over 6 is square root of 3 over 2. So square root of 3 over 2 times the square root of 3 is just 3 over 2. The sine of pi over 6 is 1/2, and therefore you get square root of 3 over 2. Okay, remember this guy is 1/2. This is where trig is going to come in big here, folks. All right, let's go rectangular to polar. Well, when you're given a point, you have to ask yourself, what quadrant is that point in? I think it's clear that that point is in the third quadrant. Yeah, let's try it again. The second quadrant. So when I go and I'm going to use the tangent. So the tangent, remember, is equal to y over x. Okay, so it's 1 over negative 1. So I get, where is the tangent negative 1? It's at these places. But this is the one I want because that's the one that's in the second quadrant. So now, once I have the angle that goes in here, now I have to find out what the r is. So I'm just going to use this formula now for the r. It's going to be x squared plus y squared equals r squared. R squared is equal to these guys, so I'm going to get r to be the square root of 2. And there. I have plus or minus. So just be careful here. R is plus or minus square root of 2. If it's plus 2, these two are the same. If I have a negative radius here, it will make this guy come all the way over there. It'll flip it. All right? So negative 2, 7 pi over 4 is the same point as square root of 2, 3 pi over 4. It'll flip over. All right? So that's why we went out so many times with the tangent. Next, we have some graphing here. So that's the polar coordinates. I know you've seen this in pre-calc, but this is a good reminder. There's going to be no calculus here, all right, for you. Calculus doesn't start till the next section with this. So r equals 2. I think we saw in the last time it's x squared plus y squared equals r squared, so that's a circle. Take a look at this one. Just pi over 3. Theta equals pi over 3. Well, tangent of theta is equal to y over x. So therefore, it's the square root of 3, because that's the tangent of pi over 3, is equal to y over x. So it's y equals square root of 3x, which turns out to be a line. Now, you may do this first before you go ahead and graph. I just have the answers right here, okay? The next one's kind of weird. Let's look at this one. R equals secant. Okay, well, I don't know anything about secant, so I'll multiply both sides by cosine. So I get r cosine of theta equals 1, because remember, this times that is 1. All right, because it's 1 over cosine times cosine. So I get this guy equal to 1, which really, this whole thing is x. X equals 1 is a nice vertical line at 1. I know, making it look easy, but you're going to practice, okay? Then you have like polar grids that I gave you in this worksheet. Hold on. Okay, you have this worksheet right here. And remember, I gave you some polar grids. You could do some graphing, okay? You could probably do some sketching in your notebook. But if you really wanted to know, here's some graphing. I'll have more graph paper for you. The next slide, okay? The next slide deals with this paper right here. And it talks about different types of graphs. All right? So here we go. More graphs. Limicons. All right, or limacons. I like to pronounce it really ridiculously. That's these guys. Rose curves. If n petals if n is odd, 2 n petals if it's even. All right, and that's shown on that sheet you could take a look at. And also, these guys are the equations for the roses. The difference between the two, if you notice, is n. Right here, the difference between them is this n. So the difference between a limacon or a limicon and a rose curve is if it has an angle that has a number with it. There's other ones, there's cardioids and things like that you could look at on this paper. This is what I want you to try for homework, right here. I'm going to check it. I'm going to give you a homework check. It's 1, 2, 7, 11, 13, 27, and 31 on page 738. A lot of it, some of it is graphing. We'll do more of the graphing in class, but a lot of this is changing from rectangular to polar, polar to rectangular. Just get you familiar and remembering that. All right? Well, have a good weekend, and hopefully you are having a good weekend, and we'll talk next week.